Let's talk about Heaps' law. So suppose you do the following experiment. Pick up any piece of text, a book, a newspaper, a web page, start reading it, and notice any time you see a word that you haven't seen before. So starting with the first word is always going to be new, you haven't seen it. The second one is going to be new, but pretty soon you're going to see repetitions of words. And then you start looking at, you start marking down every time where you see a new word, a word that you haven't seen before. And then let's start counting those new words. So let's say that V, at any point in time, V is how many new words we've seen up to this point in this piece of text, and N is the total number of words. Right. So what we're going to do is we're going to plot V against N, and this is what it looks like for our for the Associated Press corpus that we had the ZIFS example with. Right. So as you see, as you read further and further into Associated Press, which is quite large, so you're talking about what is it? About 40 million words. The number of distinct words grows kind of like a square root for a while. Okay, and I guess another way to think of what is the number of distinct words, that's the vocabulary. That's the size of the vocabulary that you've observed up until the current point in your piece of text. So that observation is basically the Heaps' law. Heaps' law says that for naturally occurring text, the vocabulary, the number of distinct words or the number of new words that you will that you have seen, is going to have approximately this form. So N is the total number of words. We're going to raise it into some power B, multiply it by a constant, so that's just to account for variations in different data sets, and that's going to give you the number of distinct words that you see in the vocabulary, the number of unique new words. And surprisingly, somewhat, in most of the data sets that you ever work with, B is going to be somewhere around 0.5. So you're really talking about a square root. In this particular case, B is 0.455, right? So very, very close. And again, you have two lines here that you probably can't distinguish. The solid line is the actual observations, and the dotted line is the fit of the Heaps' law. So what Heaps' law is saying is that the vocabulary, the number of distinct words, is going to grow approximately as the square root of the total number of tokens that you've read as you're going through text. Now you look at this and you say, well, there's a problem with that. Right? The square root is just going to keep growing and growing and growing, and that cannot possibly happen with English, right? Because we have a finite number of words. So eventually this curve should level off, tail off, right? Okay, so who thinks it'll tail off? All right, very inactive, but I'll... and that's that was my gut feeling as well. And unfortunately, that gut feeling is wrong, right? So if you take the same process, right? So here I went to about 40 million words. Now 40 million isn't that much, right? It's 1 year of Associated Press. So now let's take it to what is it? Is it 30 billion? And that's the vocabulary size. So again, the solid line is the observations. So this is in a Gov2 corpus. Gov2 is an amalgamation of news stories and all kinds of websites and government documents. As you measure the vocabulary size, it just keeps growing and growing and growing. Right? It never sort of stops, and it keeps following Heaps' law, surprisingly. So that's what square root looks like once you take it far enough. So what's happening? What are we seeing? The basic observation is, you know, we've seen about 30 million distinct words, so right there, and it still keeps growing and growing and growing. So what are all of those words that we are seeing that we haven't seen before? And the answer is they're words. They're just not words in the dictionary. Right. So what we're seeing is we're seeing spelling errors, and we're seeing a lot of human creativity in creating new words that didn't exist before. So humans like to label things. They like to come up with names for stuff that they invent. And that includes products, personal names, company names, emails. If you have a large enough collection of text, you're bound to see some code in there. So you're going to have some variable names, some keywords from the code, basically anything. So, and again, the surprising observation is this will hold for just about any collection of any human language that you can come up with. So, unless you have an artificial collection where you restricted somebody to a certain set of words, no matter what you do, the more words you see, the more your vocabulary size is going to be. So, you're going to see new words all the time. And there's a big implication there when you're building a search engine. What that means is your index will always keep growing. Right? You can never ever put a cap on the number of index terms that you're going to have. And that is the reason why. It's because the real vocabulary size, it's going to keep growing and growing and growing.